So I'm giving this presentation on behalf of Adrian Pinder, who couldn't be here today. Due to the changing dates of the forum, this interfered with, or well, overlapped, with a trip that he took to Europe for another scientific conference. So yeah. And I'll speak to Adrian's, he has a very intimate knowledge of the surveys that I'll be talking about today. So if you have any questions that I can't answer, you know, I can get back to you with those and ask him about them. The data sets that I'll be speaking about today are regarding Adrian's work on macroinvertebrates, aquatic macroinvertebrates specifically, in wetlands. And this is kind of a 30,000 foot view of what he's been involved with over the past about 3 decades or so. And unfortunately, there are actually very few wetlands included in his data sets that reside within the Albany Sandplains region. And if memory serves, I believe the only one is actually Lake Pleasant View, which we just heard about. So I'll spend a bit of time talking about that. But I'll also talk about regional patterns and some of those, what we see spatially, so throughout the southwestern portion of the state, as well as maybe how patterns in biodiversity are changing temporally as well over about the past 20 or 30 years. So with that said, the first one, back, left, sorry. There we go. Okay, great. So the first survey that I'll talk about occurred from 1996 to 1999. And as I understand it, this was kind of the first wide-scale survey that occurred of inland water bodies throughout the agricultural zone in Western Australia. And in total, they sampled 223 inland water bodies, and that's a pretty diverse array of different aquatic habitats. So that included streams, rivers, freshwater lakes and wetlands, as well as saline wetlands. And I believe they included a few artificial wetlands in there as well. So a very diverse array of habitats. And they went over this 3-year period, they sampled all of these sites a single time. So they collected information on water quality, so this included things like pH, nutrient concentration, and of course, most importantly, salinity. They also collected information on flora, aquatic invertebrates, which I'll talk about here in a minute, as well as water birds. So a pretty diverse array of different variables that they were able to collect from these sites. Now, the majority of these sites were actually within the wheat belt, but some of those sites do extend into the area of focus for this particular forum. And in total, they had about 11 sites. Now, prior to this survey throughout this region, they had only recorded about 200 different aquatic invertebrate species. Following this survey, they increased that number to 957, so it's about a 5 times increase in our understanding of biodiversity within the region. Now, within the 11 sites that are in and around the area of focus for this particular forum, they found 283 different species. So you're looking about 25 to 30% of the overall biodiversity identified within that survey is located within this particular region. And just to kind of orient everyone.
Is it turned on the side?
Oh, of course not. Wait, hold on. Oh, now it is. Thank you for that. And just to orient everyone, this little red dot down here is Lake Pleasant View. And as I understand it, most of these other sites that you see here are streams and river sites, I believe. So, but again, Lake Pleasant View is that single actual wetland that was sampled within this particular data set. Also, as I understand it, probably about 7 to 10% of those species that have been identified appear to be endemic to this particular area of Western Australia. Most of those other species are either found in other portions of WA or in South Australia as well. So, now, one of the things that we can do, so we had 223 sites across the southwestern portion of the state. So this is a pretty massive spatial analysis. So what you can do with these data sets is you can do basic cluster analyses. And fundamentally what these cluster analyses do is you stick all 223 sites you have into them along with all of the community, the biodiversity information that you have for each of those sites. And the cluster analysis just groups those sites together based on what you see within the aquatic macroinvertebrate community. So they're able to take those 223 sites and condense them into 14 different groups. Now, 6 of these groups were represented by the 11 wetlands, and I should have put inland water bodies in here, sorry about that, but 11 of the study sites, the 11 study sites in the region were compressed into 6 different groups. And that included freshwater wetlands, so your southern swamps, so that's Lake Pleasant View in particular. We also have brackish sites, with average salinities ranging from 4 to 9 grams per liter, as well as saline wetlands ranging from 28 grams all the way up to these hypersaline sites of 60 grams per liter. Now, salinity, as we know it, is one of the primary drivers of biodiversity within these regions. And the reason for that is, depending on the salinity, requires specific physiological adaptations of the flora and fauna that we see there. So that's why a substantial portion of the variability in these 14 groups can actually be explained by salinity metrics alone. And I'll kind of come back to this. I'll actually come back to these 14 groups that were identified in this survey here in a few slides, so kind of keep that in mind. Now, that first survey, spatial, right, big spatial component, occurred from 1996 to 1999. What they were able to do at the end of that survey is say, all right, well, we have an idea of how these communities, these aquatic macroinvertebrate communities, are spread out in space. Well, now what's happening to them over time? So they set up another survey where they took 25 of those sites that were representative, right? And then conducted surveys every 2 to 3 years from 1998 to 2012. There was also some additional sampling occurred that in 2021. I'll be able to speak to some of that, but they haven't analyzed all of those sites yet. So this is a temporal analysis, right? So what's happening to these sites over time, almost a 20-year span, at least for the majority of the survey. And again, they collected very similar variables to the first survey: vegetation structure, water quality information, aquatic macroinvertebrates, and water birds as well. And again, just to kind of orient everybody, here's Lake Pleasant View, and I'll actually spend a bit of time talking about the patterns that we're seeing within Lake Pleasant View. So over the course of this particular survey, they were able to identify 274 different invertebrate species, and in any given year that they actually sampled Lake Pleasant View, they had about 105 species, right? And the reason that you see a difference between the species in any given year and the total number of species is, well, the phenology or the life histories of these animals can slightly change from year to year. So depending on when you actually went out and sampled the wetland, what time of year, even if it's only a couple of weeks different, can actually have a pretty strong influence on the species that you find there. So that's why it's important whenever we're conducting these surveys is to conduct them in as many different times of the year as possible so that we can get a decent accounting of what the invertebrate communities actually look like. Now, through this particular survey, they were able to identify 2 undescribed species of ostracods known from Lake Pleasant View, as well as a few similar wetlands within the area, and an undescribed leech, and then 2 undescribed rotifers known only from Lake Pleasant View. Now, one thing to note about these species that appear to be highly endemic to the region, we haven't really surveyed that many wetlands in the area, and this is generally what you find whenever you start conducting surveys in new water bodies. You often find new species. So if we actually begin to expand these surveys like we hope to do in the future, I suspect that not only will we find new species to science, but also we'll get some range expansions on the species that we've actually seen in Lake Pleasant View. So one of the things I mentioned about this particular survey is it's a temporal analysis, right? It gives us an idea of how these communities, or if these communities, are actually changing over time. So on the first y-axis here, we just have number of species that were sampled at any given time. On the x-axis, we have years. And on this other y-axis, we actually have the depth of Lake Pleasant View, because water depth can be a predictor of community composition within these habitats. And essentially what we're seeing within this data set is there's really not much change on the number of species that you find in any given year of sampling, despite seeing, relatively large variations in the water depth at Lake Pleasant View. And the reason that we use water depth here is that in some wetlands, whenever you get large variations in water depth, you can also have large changes in the salinity regime. And as I already mentioned before, salinity is a really strong predictor of community composition. But given Lake Pleasant View remains fresh the entire time, these changes in water depth, of course, don't change the salinity regime. So this is just the number of species that they saw within any particular year. What you can do is another analysis with this, which is just an ordination analysis. And what this allows us to do is to say, okay, well, we don't see a change, really much of a change, in the number of species, but what about what species are actually present in any given year? And the only thing that you need to know about this, well, there's a couple of things you need to know about this ordination analysis. These numbers refer to those 14 groups that they identified from that original survey I had mentioned. And the closer these points are together, the more similar the invertebrate communities are. So Group 3 is more similar to Group 2 than Group 3 is to Group 11, because Group 11 is farther away, right? Pretty simple interpretation. All of these little dots here are all of the data that was collected from Lake Pleasant View. So you can see all of these dots kind of grouped together, which suggests that there's not much change in community composition within Lake Pleasant View. And then also, Lake Pleasant View is quite similar to Group 9 over here, which, if I remember correctly, is a freshwater swamp that's just west of Esperance, maybe called Mount LeGrand, but I could be wrong about that. But it is basically a site that's very similar to Lake Pleasant View. Now, what we can also do with these analyses is we can actually zoom in on all of those points to get a better idea if we are actually seeing any temporal variability in Lake Pleasant View. And what we see here is that these points, if you look at the different dates, sometimes it can be kind of hard to tell with these slightly different shades of blue. But basically, there's no real pattern that we see between these points from one year to the next. If you're actually seeing changes in community composition from one year to the next, what you'll see in these analyses is they can form lines, right? Or they can form arcs. Or if you see cyclical patterns, right, especially on an annual scale, or you'll see that if these points showed a cyclical pattern, you'd see that they form kind of a circle, right? But all of these points are kind of scattered all around, which means that that community, that aquatic invertebrate community, is really not changing from one sampling year to the next. Okay, so we've looked at Lake Pleasant View, done a bit of a deep dive into that, but what about the overall data set, right? What are these temporal patterns occurring at the regional scale? So on the y-axis here, we have regional invertebrate richness. This is just the number of species, aquatic invertebrates, that they recorded in any given year of sampling. And one important thing to note about this particular graph is not every wetland was sampled in every year of sampling. They alternated the number of wetlands that they could sample at any one period of time. And that's just due to logistical issues. But on the y-axis here, or excuse me, on the x-axis, we have the proportion of dry samples, right? So we see this decline in invertebrate species richness from, let's say, approximately 350 in 1998 to 1999, all the way down to approximately 100 in 2010 to 2011. And that correlates fairly well with the proportion of dry samples. And what the proportion of dry samples means that they just showed up to a wetland in that year and it was dry. So of course, if you don't have water, you can't sample any aquatic invertebrates, right? So what this begins to point to is these patterns that we're seeing across the region of wetlands drying out sooner or becoming dry is now starting to be reflected in some of these large-scale regional patterns in terms of what we're seeing within species richness. And again, this is, of course, a function of the particular wetlands that they sampled. But it's indicating that the wetlands within this data set are at least becoming more dry over time, which is obviously having an influence on invertebrate species richness. Now, if we do a bit of a different analysis and you just calculate the average species richness in any wetland sampled within that time period, what we see is in 1998 to 1999, all of those wetlands, which presumably the majority of them had water in them, had a richness or right around 45 or so. Well, by the time we get out to 2010 or 2011, we see that's dropped down to about 5 or 10. And again, it's that two factors I would argue that are driving this. One is the drying of these wetlands, but two, and this wasn't included in these particular analyses, but there is the potential for changes in salinity regime, right? So as I mentioned, whenever these wetlands decrease in volume or decrease in water depth, you can sometimes get an increase in salt concentrations. And in general, within inland water bodies at least, if a site is more saline, it tends to have less macroinvertebrate biodiversity within it because, again, it requires a very specific set of physiological adaptations to survive within those habitats. Now, I'm just going to hit on a couple of other surveys that occurred within this area as well. So we had a survey by Story et al. In 1993, working within the Two Peoples Bay region. They identified 247 different species. 39% were restricted to streams and 45% were restricted to standing wetlands. And then we had a bit of an older survey here from the Aquatic Research Laboratory in 1992 that focused on permanent wetlands in the South Coast, where they recorded a total of 209 different species. And now, for my portion of the talk, I'm done. I'll hand this over to Sarah now. And then, yeah, if you have any questions, I'll answer those at the end. So thanks for your time.